finding the values of the trig functions of the non-acute angles by finding reference angles, and then using those reference angles to help us decide the value of the trig function. The reference angle was the angle formed from the terminal side of the given angle with the nearest x-axis. Do you have anything that you want me to work before I get started blowing and going? Anything from Webwork or from life in general? Okay. So while he's pulling it up, I'll just kind of give you a little overview. So from last time. Way down. Way up. Today is already September 7th. A reference or the reference angle theta prime for a given angle theta is the angle formed between theta and the nearest x-axis. And so if we find theta prime this way, or that way, or that way, or that way, depending on where your reference angle is. So you use the fact that you can use this axis here as 360 degrees and this one as 180 degrees, or you can measure going in the other direction. But you measure from those angles right there. And then we use our values of theta, either 0 degrees, 30 degrees, 45 degrees, 60 degrees, or 90 degrees, where the sine of each of those angles goes 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. Yep. Cosine of those angles goes backwards. 0, 1/2, square root of 2 over 2, square root of 3 over 2, and then back to 1. Now that I'm recording, I don't see a camera. I'm supposed to see the little red dot. That's why I'm worried about this. I don't see my record, so I'm gonna try to. Where do you see it?
It's right next to the
Gotcha.
screen share.
Good, okay, so I am recording. Thank you. That's the part that I always mess up. Okay, did you find your question?
Yes.
What you got?
So it's on section 2.1. It's giving us data equals -150. We got to find all the.
Find all 6 trig functions of -150?
Yes.
Okay. Given this, find the values of all the trig functions of theta. So what we have to do is see if we can plot that to decide what quadrant that one's in. So let's see, if it's negative, it's going to go counterclockwise, and halfway around to the negative x-axis brings us back to -180. So that means -150 has to be in quadrant 3. Does everybody agree with that? So here it is in quadrant 3. So how close am I to the -180? 30 degrees. 30 degrees is our reference angle. So what we have to use is the values of all the trig functions at 30 degrees and the fact that in quadrant 3, only 2 of our trig functions are positive. Which 2? Tangent and cotangent. So the other ones are going to be negative. So the sine of negative 150 degrees is minus the sine of 30 degrees. And then up in the table, we can see that the sine of 30 degrees is 1/2. So the value here is negative 1/2. Similarly, the cosine of negative 150 degrees is minus the cosine of 30 degrees. The cosine of 30 degrees is the square root of 3 over 2. So we get negative square root of 3 over 2. To get the tangent of negative 150 degrees, we can use the reciprocal identity or the quotient identity that it's the sine over the cosine. So I take the negative 1/2 and divide it by the negative square root of 3 over 2. So you can see the negatives are going to cancel to leave me a positive number. And then to divide negative 1/2 by negative square root of 3 over 2, I'll cancel the negatives. And then I'll write that as 1/2 times 2 over the square root of 3. That simplifies to 1 over the square root of 3. And then when you rationalize the denominator, you get the square root of 3 over 3, positive square root of 3 over 3. Now we flip those numbers over to get the cosecant of negative 150, the secant of negative 150, and the cotangent of negative 150 respectively. So now comes the reciprocal identities. The reciprocal of the sine is the cosecant. Sine was negative 1/2, so 1 over a negative 1/2 simplifies to negative 2. Then the secant of negative 150 is 1 over the cosine. The cosine of negative 150 was negative square root of 3 over 2. And when we flip that over, that becomes negative 2 over the square root of 3. And then rationalize the denominators. I believe this problem asked for that. So you get negative 2 square root of 3 over 3. And then one more is the cotangent. So we'll flip the tangent over. I'll flip it over before I rationalized it. The tangent was 1 over the square root of 3. And so you get the positive square root of 3 out of that. So the sine was negative 1/2. The cosine was negative square root of 3 over 2. The tangent was positive square root of 3 over 3. The cosecant is negative 2. The secant is negative 2 over the square root, 2 square root of 3 over 3. And the cotangent is a positive square root of 3. That's something you can do? Yes, sir. Oh, thank you. Good eye. You want more problems over 2-1 or 2-2? Well, the problem is the Webwork doesn't have a heck of a lot more, but the book has a whole boatload of them. So if you can do the book, maybe I'll try to copy some down or get some out of a web page and post it on Blackboard. How about that? Post one on Blackboard with solutions for this. Yeah, it does take quite a bit of practice. So let me make myself a note to do that. Practice problems on 2, 1, and 2, 2. Tell you, a really good site for anytime you need to learn some math is that Khan Academy. If you just do Khan Academy and reference angles in degrees, I think you'll find quite a few worked examples in the video. Yes, sir.
So is there any updates on the tracking of the books? Because I still haven't gotten my textbook yet.
Geez.
Yeah.
No, see, I don't know how to make the sausage. I just see the sausage. I don't know what happens between classes start and what you guys do. Wow.
Yeah, it's ridiculous. I don't know what happened. I haven't gotten mine yet. And I've gotten twice over the past like 2 weeks.
Who'd you order it from?
We brought up like the online version of the bookstore.
Okay. I think you can have up to 2 weeks of free access through the the My Math Lab site. I'm not going to use My Math Lab, but I do have a My Math Lab site. So if you want free access for 2 weeks to the online textbook, send me an email and I'll send you the register for the course information. Just don't pay at the end of the 2 weeks. Hopefully your book will be in by then. Okay, you get free access to my, what I call it, My Math Lab. And on My Math Lab, free access includes a textbook. Just don't pay after the free 2 weeks is over because I'm not going to use My Math Lab. Okay, so I don't set up assignments or anything, but the textbook is there. But send me an email so I can show you how to access that textbook. I probably should have said that a long time ago, huh?
Yeah.
But then I thought everybody just had this trig stuff in their heads. You don't? What else?
A question from, I guess it's probably the week before.
Okay.
And a couple problems that gave us something like sine would be -3/5.
And then you have to find the other trig functions?
Yeah,
Okay.
but I guess that was all easy. What I was confused about was how we can have a y coordinate that's a negative square root.
It could be any, if it's going to be a negative y, then it's going to be some sort of y value that's in quadrant 3 or quadrant 4, right? That's where the y values are negative. And then I believe they tell you in which quadrant the angle has its terminal side,
Most of algebra out of this equation when you learn trig.
right?
The
Negative
logic
square
does
root.
not apply.
It shouldn't, because we're not all the sides are going to be integer values, right? So a square root is square root of 5 is a little bit bigger than square root of 4, so it's 2-ish, right? So the only thing about what you said that was probably would be confusing was the hypotenuse has to be the longest side. And so when you said 3 over the, or -3 over the square root of 5 or something, 3 is bigger than square root of 5, so it'd have to be upside down. But I'll work one just like that right now. So let's go back to the right triangle trigonometry. That's page 1. So let's do this example. This is right triangle trig, because this is what we're going to be doing today. So we got to know how to do this kind of thing. Okay, so suppose the sine of some angle is equal to, okay, so now let's see. Square root of 5 we said was 2-ish. So let's go negative square root of 5 over 3. And theta is in quadrant 4. Find the rest of the trig functions of angle theta. Okay, so again, sine was y over r, where r is the hypotenuse. So if I know I've got a quadrant 4 angle, I stick it in here randomly. So here's angle theta, and I drop the perpendicular to the nearest x-axis. Here's the y value, and so that's going to be the negative square root of 5. And here's the r value. And then we need to find the x value that goes with that. And in any right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. So in our picture, we have that x squared plus that negative square root of 5 all squared should be equal to 3 squared. So I have x squared plus 5 is equal to 9. Now, if I put the 5 over there with the 9 by subtracting, I get that x squared is equal to 4. So x is, in this case, positive 2. Why did I choose positive 2 instead of the negative 2? Because I have to go over to the right in the x direction and then down. So x is positive for the values in quadrants 1 and 4. So here we have x is positive 2. And now from that, we can get the other trig functions. Cosine of this angle theta is x over r. X was 2, r was 3. Tangent of angle theta is y over r. So negative square root of 5 over, I'm sorry, y over x. I don't know why I said r, y over x. Negative square root of 5 over 2. Now start flipping them. The cosecant of angle theta is r over y. So I flip the sign and get 3 over negative square root of 5. Secant of angle theta is r over x, or the flip of the cosine. So that's 3/2. And then finally, the cotangent of angle theta, flip over the tangent of angle theta. So that's 2 over the negative square root of 5. And if you want to rationalize them, you can. This would be negative 3 square root of 5 over 5. And this would be negative 2 square root of 5 over 5. Okay? But again, that's what we're going to do today. We're going to solve right triangles. We're going to find all 3 sides. We're going to find all 3 angles using this right triangle trigonometry stuff. Anything else? Anybody? How you doing back there in the back row? Everybody awake back there? Can you see well? Okay. Yes, sir.
I'll get one more question on the Webwork.
Okay.
I guess for the last problem, it says it gives us 10 theta equals negative 1, we're gonna find all values.
Find all values of theta in 0 to 360.
Yeah.
Okay, so tangent is going to be a negative number in which 2 quadrants? Quadrant 2 and 4 makes tangent negative. So we're going to find the reference angle at which the tangent is a positive 1. And then we're going to use our subtracting from 180 or 360 to get the angles 2 and in quadrant 2 and 4. So we use the fact that tangent is negative in quadrant 2 and quadrant 4. There, I can mix up Roman numerals and regular numerals. Now, to find out where tangent is negative 1, tangent was the y over the x or the sine over the cosine. So we need to know an angle first in our little table of values at which the sine and cosine are the same, so that I can get a tangent of 1. 45 degrees. So our reference angle is 45 degrees. So now let's figure out how to get the ones in quadrant 2. I need to back up 45 degrees. And I need to back up from 360 degrees to get those. So let's go back in quadrant 2. This is 180 degrees. So I start with the 180 degrees and I back up 45 degrees. So if I'm backing up, I'm going to subtract. 180 minus 45 is 135. So that's one of our angles. Now we're going to go over here to 360 degrees. We want a reference angle. We want our angle to be a positive number. So I'm going to back up from 360 degrees. That means to get the quadrant 4 angle, I take 360 degrees minus 45 degrees. So I'm thinking that's 315 degrees. That make sense? Ignore the sign and find the angle in quadrant 1 as your reference angle. Then state which 2 quadrants you're working in and then kind of draw a picture and figure out how to get there from 180 or 360. Yes, sir.
How did you get, the reference angle was 45?
I know I needed sine over the cosine, and the only place where sine over cosine is going to simplify to 1 is 45 degrees. Okay? None of these, the fraction has to have the same denominator and numerator. So that's kind of the memorizing part. Recognize which values you know or don't know as values out of this table. Okay? Anything else? We're all good? Everybody staying okay? I haven't really looked to check the progress on Webwork. I usually like to check to see if all of you are doing it already. So if you've got a bunch of zeros already, that's the wrong start. So make sure you get, I'll open them up. Just send me an email. I'll open them up for you. Get busy on them. Yes, sir.
You have to complete all 7 100% to receive full play. Is it completion based? So like if you like base the problems, if you like 6 the problems, will you still receive?
Yeah, you'll get credit. It does give partial credit. So, but I want your goal to be 100% each time, because this is the cushion that you're building so that if you ever have a bad test, that you've got this nice cushion of Webwork grades to bring your grade up. So there's no shame in getting 100% on all of these. I'll be glad to help you get 100% on all of these. Just do your part. Okay? Anything else? They said there's going to be clanging because they're redoing a classroom somewhere around here. So there it is. I don't remember this thing being in here. Where did this come from? I know, we could, what's good? What could we watch? Borat. Potty humor. Thought you guys are much more advanced species than that. They are, not me, man. Okay, so let's start section 2.4. Section 2.4 and 2.5 are kind of the same idea. So we'll take our time and go through those. This is page 3. There was a bit on section 2.3 about how to use your calculator to find these values. I said we're not going to use calculators on your test, but you probably need calculators for Webwork. So as we're doing these problems, I'll do some calculator problems to help you see how to do it on your calculator. And a lot of times on Webwork, it asks for a certain number of decimal place accuracy. So try not to round your answers until the final answer, right? If you round each step, you're going to have a round off error in each step. So if you're doing things for Webwork with exact arithmetic, don't round off until the very, very end. Okay, so we're in section 2.4. And the basic premise is how to solve a right triangle. So a right triangle's got 6 pieces, 3 sides and 3 angles. So if someone hands you a triangle in which only some of those are filled out and says, solve the triangle, your job is to find values for all 6 pieces. And I'm going to label the triangles like this. I'm going to try to be consistent with the way your book labels them. They always mark the right angle as angle C. And so I'm going to go this way, where the angles are going to have capital letters designating them. And then the sides opposite the angles are going to have lowercase letters. So to label the side opposite angle A, I'll put a little a. The side opposite angle B, there's my little b. And now it's real hard to tell a little c from a big C. So maybe I'll kind of make a little cursive C for the little c. Remember back when you had to write in cursive? You never had to write in cursive? So my little c will try to be kind of, had a little flap on it like I'm writing it in cursive. So capital letters represent the angles and little letters represent the sides opposite the angles. So to solve a triangle, to solve a right triangle means, need that comma, you find the lengths of the 3 sides and the measures of the 3 angles. So in all of this, you're armed with the fact that the interior angles have to add up to 180 degrees, and the 3 sides satisfy the Pythagorean theorem. So you have that leg squared plus leg squared is equal to hypotenuse squared. And you have the angle measurements, the measurement of angle A plus the measurement of angle B plus the measurement of angle C has to equal to 180 degrees. Then depending on what you're given, we have the right triangle relationships, that the sine of any of these angles is opposite over the hypotenuse. The cosine of an angle is adjacent over hypotenuse, and the tangent is opposite over adjacent, and so on. So you have your SOHCAHTOA relationship. There's our plan right there on the left-hand side. So here's a mini example. So given this triangle here, where I give you the hypotenuse length of 17.6 inches. There's our right angle at angle C. I'm going to give you angle A is 32 degrees, 30 minutes. And the rest is up to you. Find the length of side A, find the length of side B, find the measure of side of angle B. We're Which would you like to do first? Let's get the angle B. We know the angles have to add up to 180 degrees and one of them is 90 degrees. So that means the other two angles have to add up to 90 degrees. So angle B has to add to angle A to give us 90 degrees. So first, to get angle B, we take 90 degrees minus angle A. So I'm going to take 90 degrees and I'm going to subtract 32 degrees, 30 minutes. So I've got to borrow from here. I take one of the degrees away. Now there's 89 degrees here. 1 degree is how many minutes? 60. So I'm moving that over here as 60 minutes. Now I can subtract 60 minutes minus 30 minutes to give me 30 minutes. 89 degrees minus 32 degrees is 57 degrees. So there's angle B. Now we're going to work on the sides. I'm given angle A. I can find side A using the fact that side A is opposite angle A, and then I also have the length of the hypotenuse. Now the hypotenuse is given with 1 decimal place. So we're going to do this with 1 decimal place accuracy all the way through. Okay, so to get angle A, we're going to use the fact that the sine of angle A is side A over the hypotenuse. Let me just write that as opposite over hypotenuse first, and then I'll go with the A. So I need to find the sine of 32 degrees, 30 minutes. Opposite side is A, and the hypotenuse is 17.6. First, I'm going to solve this for A, and that's the way that you're going to write it on your test. Then I'm going to go ahead and whip out the calculator and get the decimal value. So if I have my calculator, I can find that number on the left-hand side pretty easily. Once I have that number to solve for A, what do? So that's the way you would leave it on a test. You would say A is equal to 17.6 times the sine of 32 degrees, 30 minutes. That's exactly what you would put on your test right there. But for Webwork, we've got to put in a decimal for this with 1 decimal place accuracy. Let me see if you're able to see my calculator once I put it on. Let's see if you can see any of that. That looks pretty good, huh? Okay, so I need the sine of 32 degrees, 30 minutes. And I'm not sure how to get this. Let me check my mode here. My mode is currently in degrees. You've got to make sure that you're in the degree mode as well before you start. You can kind of see that. And now I've got my sine button right there. And I'm going to, I'm sure there's a way to go degrees and minutes. I just don't know on this calculator how to do it. So I'm going to go ahead and convert 30 minutes to a fraction of a degree. How do I do that? Divide by 60. So 30 divided by 60 is kind of easy. That means I've got 32.5 degrees. So I'm going to, but I could enter it just like this. I could say it's 32 plus 30 over 60 if I didn't have such a nice fraction that I could do in my head. So I've got the sign of 32 plus 30 over 60, which is going to do my 32.5. And then when I enter that, I get 0.537, blah, blah, blah. But instead of rounding right now, I'm going to do the next step, which you told me was to multiply by 17.6. So now I'm going to take that number and just multiply by 17.6, and I get 9.45. I only want to use one decimal place accuracy, so I'm going to need to round that 4. So we got 9.5 is the length of A. I'm going to use the trig function to get B instead of using the Pythagorean theorem, just because it's a trig class. I think it would be a little bit more fun. Which trig function is going to get me side B? Well, I'm not going to use the Pythagorean theorem. I'm going to use a trig function. I'm going to use a cosine, right? Cosine of that given angle is going to help me find side B. So now I'm going to say that the cosine of the 32 degrees, 30 minutes is equal to adjacent over hypotenuse. And so again, on your test, you would just write that B is 17.6 times the cosine of 32 degrees, 30 minutes. But I'm going to go ahead and get it to one decimal place. So here we go again. Okay, so I'm going to go ahead and do it in one line. I'm going to do 17.6 times the cosine of my 32.5. And I get to one decimal place, 14.8. Now you could have used the Pythagorean theorem here. I just wanted to use a cosine function just to emphasize on how I could use a calculator to do that. Okay. All right, so that's the kind of thing that we're going to do. Let me give you two of the sides and show you how to find the measure of an angle. So I'm ready to go to page 4. And so in my next example, I want you to find or solve the right triangle ABC if you're given little a is equal to 41.2 centimeters and little c is 60.5 centimeters. So when it's stated this way, just get in the habit of drawing angle C as the right angle. And then I don't care where you put the A and the B. So angle C is always the right angle. So little c is right here, the hypotenuse, opposite angle C. Little a is opposite angle A. And so I guess we need to find little b, and then we can go ahead and find the angles. Is that the order in which you would do it? So this time, let's set up the Pythagorean theorem to get that little lowercase b. A squared plus b squared is c squared in our pictures. So let's go ahead and start there. So I have 41.2 squared plus b squared is 60.5 squared. Okay, so here's how you would do it on the test since you won't have a calculator. Just solve this for B. So the first thing you do after you square this number is you take it away from that one, right? And then the last thing you do is take the square root. So here's how you could leave it on your test. Okay. But let's go ahead and get that number. So I'm going to take the square root. There's the square root. I got a sum in there. 60.5 squared. Where's my squared? Right there. Minus 41.2 squared. Close up my square root. And so I'm doing one decimal place accuracy again. We'll keep 44.3 as side B. What I'd probably do on a test is make these numbers so that they're numbers that you can square. 3, 4, 5, 5, 12, 13, that kind of thing. Okay. Okay, so we've got the three sides. Now I need some angles. So here's the part that comes from section 2.3. To get angles, we've got to set up our trig relationships. So for instance, if I want angle A, I know the sine of angle A is the opposite over the hypotenuse. This is my next. People reading the notes later on, first comes first. Next comes next. So I'm going to write down what I'm going to use. I'm going to write down the fact that the sine of angle A is equal to little a over C. So in our picture, the sine of angle A is equal to 41.2 divided by 60.5. So how do I get angle A? Any ideas? That's right. In order to find this angle, I've got to use a button on here called the inverse sine. It's a second function above the sine. There's my sine key, and it's the second button function right up here. So the way we're going to punch it in the calculator is that angle A is equal to the inverse sine of this ratio here. So you can do it, you can leave it right there on your test. But for Webwork, I would hit my second function to get the inverse sine. And now I've got some parenthesis action going on here. I need 41.2 divided by 60.5. Okay, so what is the measure of angle A going to be? 42.9 degrees. What if Webwork says, state your answer in terms of degrees and minutes?
So wouldn't you just do the 9 over 60?
Other way, when you're given minutes, you convert it to decimal by dividing by 60. When you're given decimals, you convert it
Oh,
by multiplying
yeah.
by 0.9, 60 times 0.9. So if you wanted to put this in terms of degrees and minutes, you would do this. You would say that that's 42 degrees plus 9/10 of 60 minutes. So 9/10 of 60 minutes is 54. So it's 42 degrees, 54 minutes. It depends on what Webwork wants. Okay. All right, now we can get angle B using the fact that angle A and angle B in any right triangle have to be complementary. So what number do I add to 42.9 to get 90? So this gives me 0.1 gives me up to 43. 7 more gives me 50. 50 plus 40 is 90. So 47.1 degrees. What is that in degrees and minutes? 47 degrees and 6 minutes. 0.1 times 60 is 6. Any questions over what we're doing there?
So would you write 0.6 if it's 6?
Doesn't matter.
All right.
Doesn't matter to me. What did I write? I wrote 0.6. So that's what I'd write. I'd write 0.6. Sometimes I'd write 6. I just want to keep you all on your toes. Or right now on your rumpus. Okay, now what we're going to do is try to describe these situations in terms of word problems. And a lot of our word problems talk about something called an angle of elevation or an angle of depression. Both of those angles are measured from the horizontal with eye level. So if I'm talking about the angle of elevation to that little gizmo up there in the right-hand corner, then I measure from the horizontal to where I look up. That would be the angle of elevation. Now, if I'm standing on top of a building and I'm looking down at a person on the street, then I'm talking about the angle of depression, measured from the horizontal at eye level down to the angle formed where I see that person. So the angle of elevation. So here's a person right here. I missed my calling. And here's a top of something. I don't know, maybe let's make that a flagpole. So from the horizontal to the top is the angle of elevation. Okay, so we're assuming that these links or this length is negligible. The angle of depression is when somebody's looking down. So from this point to this point. So we put the horizontal there, drop down, and there's the angle of depression. Okay, so I'll get that in a few minutes. Let's look at some class examples. I had some class examples on a handout. You wanted to call them up from Blackboard. I printed them out with bigger spacings so that I can do them in class. Here's my first one. A ladder 500 centimeters long. I don't know who measures ladders in centimeters. That's already dumb. A ladder 500 centimeters long leans against the building. If the angle between the ground and the ladder is 57 degrees, how far from the wall is the bottom of the ladder? Round your answer to the nearest tenth, I guess tenth of a centimeter. A ladder measured in centimeters. Who made this handout? Me? A ladder 18 inches long. All right, let's draw a picture. Draw a picture of a ladder leaning against a building in our perfect right triangle world. So here's the ground. There's the building. And here's where my artistic ability comes into play. That, boys and girls, is your ladder. It's like you're there. I didn't make my angle big enough. That should be 57 degrees. Doesn't look like it. Looks more like 30-ish degrees, but it isn't. It's 57 degrees. Why did it do that? Was that just me, or did that focus on its own? Sometimes my life is like that. Wow. There's my 500 centimeter long ladder. And now let's put a variable for the length that we want to find. It says, how far is the wall? How far from the wall is the bottom of the ladder? So there's the bottom of the ladder, and there's the wall. We want to know this length. So stick your variable right there. Let me use an X. And we're going to make our right triangle with the wall and the ground. So if that's my picture, good. Gosh, there it goes again. I'm not doing that.
It's probably because
When I move my
drawing,
hand.
Yeah.
Okay, so there's a trig function talking to you. Cosine, because that X is adjacent to the angle, and the ladder's the hypotenuse. So the cosine relates those two sides, unless you're a weirdo and want to use a secant. Any weirdos in here? I could have called that one. I had somebody volunteer to be a weirdo. Isn't that weird? Okay, so I'm going to use a cosine. The cosine of the given angle is the length of the adjacent side over the hypotenuse. So that's what I'm going to write here. Cosine of the 57 degrees is the adjacent side over the hypotenuse. So what would you do to find X if this were on your test? It's multiplied by 500, right? So X is going to be 500 times the cosine of 57 degrees. Don't need these parentheses, but I'm going to put them in there. And now I'm going to do this part here. I'm going to round the answer to the nearest tenth. So I pull out the old calculator and see if you can see it. Yep. So I'm going to clear that. Take 500, multiply it by the cosine of 57 degrees. To the nearest tenth means I'm going to just keep the 0.3. X is 272.3 centimeters away from the base of the building. Easy enough? Okay, the next one's going to use an angle of depression, so I get to draw this. You ready for the next one? Here she be. If you want still that one, I'll pull it down a little bit. Okay, blur focus. Remember when you go to the eye doctor? And he says, which is better, 1 or 2?
Yeah. What's either one beer? Yeah.
They're both blurry. Okay, so from the top of a lighthouse, 160 feet high, how many inches is 160 feet? No. The angle of depression of a boat out at sea is 24 degrees. Find to the nearest foot the distance from the boat to the foot of the lighthouse. The foot of the lighthouse is at sea level. Okay. All right, so here's the lighthouse. Now, I'm not really a lighthouse person, so I don't know what they look like. But that looks like a house. And then if I make it glow, it looks like a very sharp pencil.
Put a window, it'll look like a lighthouse.
Where would I put my window?
No.
There?
There we go. It's a
It's a crayon. You know, I would if I didn't have to go back to school and stay up all night. Not wanting to do that. I know I shouldn't draw pictures where there's architect students in here. I already took Trig. And back in my day, that's exactly what lighthouses look like. And since you haven't seen one because you're in Lubbock. Okay, look, here's the sea. That's pretty dang good, isn't it? That's pretty good sea right there. And there's the boat.
Oh my God.
actually not bad.
All right, so I'm gonna measure the angle of depression. There's the horizontal. There's the angle of depression. Right to there. That's the 24 degrees. Okay, so I can make this right triangle up here. And the boat to the lighthouse has the same length as this point above the boat to the lighthouse. Agree? So this length is the same as that length. So if I put an X here, that's going to be the same as the X here. There we go. I left off the 160 feet, but I've got this right triangle up here. And I want to find the length of X, which just so happens to be adjacent to that angle of depression. And then I have an opposite side. I have an adjacent and an opposite. So you tell me the trig function. Sine and cosine needs the hypotenuse. So I'm going to use tangent. Tangent is opposite over adjacent. I could use a cotangent, but look at my problem about using a cotangent. See this calculator here? I only have sine, cosine, and tangent. So I'm not going to use a cotangent. I'm going to use a tangent. So I'm going to use the fact that the tangent of the 24-degree angle, opposite over adjacent. So the opposite side is the 160 feet. The adjacent side is the one I marked as X. So to solve this for X, the first thing I would do is multiply both sides by X. And then the next thing I would do is divide both sides by the tangent of 24 degrees. So for your test, you would just do your algebra like this and leave it right there. But I'm going to whip out my handy dandy calculator. Then I'm going to compute that stuff to the nearest tenth of a foot, I believe it said. And so I'm going to put it in just the way I see it. 160 divided by the tangent of 24 degrees. To the nearest tenth would be 359.4 feet. So the boat to the lighthouse is 359.4 feet. Up, 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 up. Okay. Questions?
Yeah.
I can even make it go blurry. Oh, God. Get out of here at 11:20. Everybody still awake? Everybody at home still awake? 12:20. 12:20. Oh, that's one. This is, I know. I don't know what time we get out of here, but I know what these people are doing at home because I attended a Zoom meeting today. I had an auditor's meeting this morning and I turned it on and then I went running. Zoom meetings are awesome. I love it. I love it. Of course you're still there. All right, so I've got 3 people somewhat functioning. The rest are gone. Okay, I've got another one. Let me flip it around. Okay, here's a little group participation because you are in this problem. You are a block away from a skyscraper that is 780 feet tall. Your friend is between the skyscraper and yourself. The angle of elevation from your position to the top of the skyscraper is 42 degrees. The angle of elevation from your friend's position to the top of the skyscraper is 71 degrees. To the nearest foot, how far are you from your friend? You stalker, you. So we're going to draw a skyscraper. Then we're going to draw 2 people that are separated by distance and the angle of elevation from each person to the top of the skyscraper. And then we're going to figure out how to find the distance between them. The skyscraper is going to look a lot like a lighthouse, but without the little pointy thing on the top. There's the ground. This is your friend. This is you. Now you're looking up. Your friend is closer, so it's a steeper angle from friend to top. From friend to top was 71 degrees. Now from you to the top is 42 degrees. And the question is, to the nearest foot, how far are you to your friend? So from here to here is what you want to find out, given that the skyscraper is 780 feet tall. So that X right there isn't even a side of a right triangle. It's a side of an obtuse triangle. I'm going to need to find a side of a right triangle. Which side do you think I should find? Which should I find first in order to work toward this? Okay, the 42 will give me this big triangle here, so this is involved in it. So I'm going to need a variable right here. The distance from your friend to the building. So grab another variable. Yes?
You got 71 on the other side of the angle, then could you just subtract 130? You just subtract some 180 across these ones.
But I don't need the obtuse angle. I can't use my right triangle trig on a non-right triangle, right? At the end of the semester, we'll have something called law of sines that we don't need to worry about having a right angle anywhere. We can use a law of sines to find that distance there. But everything we deal with right now has to be with a right triangle. And even if I knew this angle here, there's no right angles in there, so I can't do sine is opposite over adjacent. I don't even have the hypotenuse, right? So I'm going to look at this right triangle here first and call the leg of that right triangle A. A is the distance between let me move that A out of the way. The friend and the base of the skyscraper. So I'm going to find A first. Which trig function and the 71-degree angle will help me find A? Tangent. Again, I've done opposite and adjacent. So next I'm going to write that the tangent of 71 degrees is 780 divided by A. Opposite over adjacent. And so swap places with the A and the tangent of 71 degrees. Okay, now I want to use the 42 degrees. The 42 degrees and the 780 and the other side involves looking at the other side as the sum of these two things, right? This side here has a length of A plus X. So I can also say next that the tangent of 42 degrees is 780 divided by A plus X. And so if I solve for the X from that, first I'm going to multiply both sides by A plus X and divide by the tangent of 42. So I'm going to swap places between these two. A plus X is 780 divided by the tangent of 42 degrees. X is our unknown, so I'm going to subtract A from both sides. 780 divided by the tangent of 42 degrees minus A is equal to X. And I have A above as 780 divided by the tangent of 71 degrees. So on a test, that's how you would write it. You would say X is 780 divided by the tangent of 42 degrees minus X, 780 divided by the tangent of 71 degrees. And now I'm going to do that on my calculator. And put it right there. Do you follow those steps okay? Okay, so I'm going to need 780 divided by the tangent of 42 degrees. Tangent of 42 minus 780 divided by the tangent of 71 degrees. And so I get 597.7. Let me look at here. To the nearest foot, how would I answer that question? 598 feet? That sounds awfully big. That you're 598 feet away from your friend? So let me check my numbers one more time. Yes.
So on the test, so we're not going to use calculator, so where would we stop?
Right here. Yep, that's what I got again. So here's where you'd stop for your test. Any questions on any of that so far? Okay, we got another one. At 10 a.m., a person observes a hot air balloon climbing vertically in the air from a point 300 meters away from the launch pad of the balloon. The angle of elevation to the top of the balloon at this time is 25 degrees. At 10:02 a.m., the person observes the angle of elevation to the balloon is now 60 degrees. What is the change in altitude to the nearest meter for the balloon over the 2 minutes between the first and second observations? So at 10 a.m., the balloon is already in the air, it's climbing. And there's no wind, so this balloon is going straight up. And in 2 minutes, it's changed from an angle of elevation of 25 degrees to an angle of elevation of 60 degrees. So I'm going to draw it like this. First, I'm going to draw it at 10 a.m. So here's the balloon. It's got the little basket down here. It's climbing vertically. And it's right here at, we're going to measure to the top of the balloon. So from here to here at 10 a.m. is, don't know. But I do know that I'm 300, or this person is 300 meters away, and that the angle of elevation at that time is 25 degrees. So that's from the horizontal to the top. That's at 10 a.m. 2 minutes later, let's put the balloon right here. Two minutes later, we got from here to here. And now the angle of elevation is 60 degrees. So that's this entire angle here. To the nearest meter, what is the change in the altitude? So this time what we want to measure is this piece right here. So I'm going to put my variable right there. So we want to find that x. Again, notice that that x is not part of a right triangle. So what we'll have to do is kind of build on it the way we did before. Isolate the right triangle that has the 25-degree angle. Then look at the right triangle that has the 60-degree angle, and then find the x. So I need this piece. Here's my right angle. I need this piece right here. We call it B this time. And then we can use this whole piece out here. And that whole piece will be B plus X. So just look at that little triangle down at the bottom with the 25-degree angle. B is opposite that angle, 300 feet is adjacent that angle. So we're talking tangent again, right? So our first step is saying that tangent of 25 degrees is the opposite over the adjacent. Opposite would be side B, the adjacent is 300. Solve for B to get B is 300 times the tangent of 25 degrees. The next thing we do is we look at the big triangle. So the big triangle looks like this. It's got a 60-degree angle. Come on, get up there. got a 60-degree angle there. It's got 300 here. And then we've got this side here, b plus x. Good. So in that picture, the tangent of 60 degrees is b plus x over 300. But we can figure out the tangent of 60 degrees, at least as a radical. Tangent of 60 degrees is the sine of 60 degrees divided by the cosine of 60 degrees. Does anybody know the sine of 60 degrees? It's square root of 3 over 2. Sine, what did I say? Sine was square root of 3 over 2. Cosine then is 1/2. So notice that the tangent of 60 degrees is square root of 3 over 2 divided by 1/2. And so if we divide the square root of 3 over 2 by 1/2, we would be multiplying by 2 over 1. So the tangent of 60 degrees is the square root of 3. So let me put that over here. I get the square root of 3 is equal to b plus x divided by 300. Our goal in this problem is finding x. So let's now solve that equation for x. We'll multiply both sides by 300. And we have 300 times the square root of 3 is equal to b plus x. Now subtract b from both sides. 300 square root of 3 minus b is equal to x. We have b from our first step. So what we're going to do is put that in where the b is. So I'll put that over here. I get that x is 300 square root of 3 minus, where's b? 300 tangent of 25 degrees. So that's where you'd leave it on a test. But for this one, we want to the nearest meter, the value of that. So here's what I last wrote. Now I'm going to enter that in the calculator here. 300 square root of 3 minus 300 tangent of 25 degrees. And I get to the nearest foot 380 feet. Meters. Yes, sir.
On the test, we have to write the tangent 60
If it's a known angle, I'd rather you give me the value, because that's part of what I'm testing you over. Okay, I have a few more examples to finish next time. So if it helps you print this off from Blackboard, then you don't have to write all the questions down. And I've got, I think, another Webwork opened for you. If not, I'll open one real soon.
Can we move that so I can take a picture and write it down for everybody?
Even better.
Oh, I'll take a picture from there.
Thank you.
Any questions for you guys at home? And I'm going to stop and hope that this is recorded. Stop the share and log out. Yes. Let me get this off so everybody doesn't know your problem. Unless you want everybody to know your problem.